Hi everyone, this is Chris Schaefer, and this is my brief presentation of exercise 2 for dsc425. The dataset I chose to use was the Sunspot dataset, which is a built-in dataset in our studio, or at least the version I've been using. So it counts the mean number of sunspots each month over a span of 230 years. I guess it's the mean number because you had multiple people counting these to help smooth out human discretion. And the data here actually shows the roughly 11-year cycle in which the sun's surface warms and cools due to magnetic shifts. And you can see over there on the left, that's the entire history. On the right is zoomed in to about a 20-year period, so we can see those oscillations a little cleaner. Here we have a histogram of the sunspot counts, which is always kind of interesting. So they have this sort of J distribution of values. So we're likely to see 0 to 100 sunspots, and more than that, it's kind of rare, but it does happen. The normal QQ plot on the right shows some expected behavior, along with the diminishing distribution of values in the J curve on the left. You will see that manifesting itself on the right side of the normal QQ plot by sort of pulling away from the line. And then on the left side of the QQ plot, you have it flattening out because, of course, we can't have negative counts. So it levels out around 0. So applying the autocorrelation function helps discover repeating patterns if they weren't already obvious enough from some of those sinusoidal waves we saw. This also reflects that pattern, and I used a time lag of 11 years worth of data, so 132 months. So we see that the maximum autocorrelation or self-correlation occurs at the beginning and end of those 11-year-ish cycles. And then it also shows minimal correlation or about zero correlation at two nodes along that cycle as well, around year 3.5, or yeah, year 3.5 and 7.5. So I attempted some simple linear modeling with R like we did in class. And over on the right, you can see the image of the entire data with the regression line for the entire data. Obvious that this time scale isn't very suitable for linear regression, although I guess it is interesting to show that there is a slight trend upwards in the number of sunspots. Don't know if that actually means anything or not. And then here we have an analysis of the residuals from said regression line. Um, since the regression line didn't really fit the shape of the data at all, it's not surprising that the residuals sort of maintain that oscillatory shape over on the left there. And then on the right, we see the distribution of the residuals. And what that image implies is that the model tends to underestimate or undercount the number of sunspots in a given month. So that's all I had for you for exercise 2. I will talk to you guys later. Thanks.